Hello everyone, and welcome to Handmade Hero Show, where we code a complete game live on stream. Last time we were programming, we determined that in order to actually do a nice solve for our entity collisions, we actually do need to do a wider check on, like a wider voxel check, which originally I'd considered, and I was seeing whether I could get away without it. But it doesn't really look like you can. Now, I don't know that that necessarily means that you want to do a full gridded check a priori, but it does kind of mean that we probably want to at least structure the collision check to be more like the one in the witness, where we look at the region first to see like what the voxel span is, and then we do checks on, we remember which vertices we have checked and check new vertices as we need to in order to figure out where we're actually going to move through. This solver is a lot easier than the witness because it's just an open space free 3D solver. The witness has a really the witness is the very hardest version of the collision problem because it has it isn't a game where you move through 3D space and are stopped by objects. That can happen, but the primary thing that happens in the witness is that the area you are allowed to walk is actually the thing that the artist is telling you. So first you have to solve to figure out where the walkable surface actually is, and then you solve for any collisions, which is a totally different problem and much harder. In our case, we don't have that. We are just doing solves for things that are saying, I want to move through 3D space along this vector. There's no need to solve for any movable area or anything like that because it's not something that's specified. Instead, the only thing that's specified is where you, like, things that will stop you from doing that motion. So that's all we have to worry about, which is definitely easier. So this should be pretty easy. It's just a question of writing the routine in a sensitive enough way that we aren't spending too much of our time testing points that we don't need to test, or storing too much information and using more memory than we should, and things like that. But, you know, on the whole, it's definitely an easier problem. So I'm going to go ahead and open up the editor here. I guess I'll just type CMD there. And let's go ahead and do a build. So where we left off was we had been drawing some stuff, and the drawing was so that we could investigate our routine better, and we kind of we did investigate our routine better, and we can sort of see what's happening wrong here. And what we determined, the reason that, you know, the thing that motivates this particular change is that you can see that, like, we never really test these outside points. So we never learned that we could have placed the sphere here. And the reason for that is that we weren't actually, we only use things from our side to determine whether we could have gone into there. It's not like we use the cube we're moving from to determine whether we could have gone in here or not. And so, for example, the fact that we could have moved into this cell and then into this cell and gotten closer is never identified correctly by this routine, because the routine only looks to see whether or not you could have cleanly moved out of a cell directly into another cell that is closer. And so that doesn't really help, because in cases where you're trying to move around the edge of something, which is what's happening here, it will never correctly detect that L shape that it could have moved through. And so the solution to that problem with this kind of a solver is that we would need to check these independently as a search, where we don't require intermediate cells of the search to always be closer, right? So you can think of this as being sort of in the family right now of like A star without the ability to, I mean, it's not really in the family of A star. So there's lots of different things for, you know, like for shortest path solving and that sort of stuff. You could think of something like Dijkstra's algorithm. And those are always guaranteed to get the correct answer because they check everything, right? Then there's something like A star, which says, look, we're still going to check everything, but we're just going to prioritize checking things that are closer than where we already are, so because we'll find the path faster that way, right? You can think about this as the A star without the actual prioritization, and rather we only check the things that get closer. And while that oftentimes will find the correct path, it only finds the correct path if you didn't have to go through something further than where you are first in order to get there. So it's kind of like A star without the backtracking, and without the backtracking, A star won't find paths sometimes. That's why there is backtracking in an algorithm like A star. So what we need to do here is turn this into more of a proper A star style search. Obviously, this is not A star, but it's similar. We need to turn this into a similar kind of algorithm where we are checking these nodes regardless of whether the node actually gets you closer or further. We check them in a certain locus to determine whether or not you can get further than where you are at the moment. And what we want to do is, if we do want to use a criteria such as we check cells that get you closer to your target, if we do want to employ that criteria has to be employed as an optimization. So it doesn't have to happen. It's just optional that it happens, so that we are speeding up the algorithm with that, but not requiring that that be true of the final path, so that we can still find the paths around complex shapes like this, where there's like an L or something, and we want it to smoothly find the route around it. So what we need to do for that, if we go to the move entity function, the way you can see that it's working currently is it just checks one voxel cell at a time inside a loop, and what it does is it exits the loop when it determines that it's tried where it needs to go. And we tried some like stuff in here where it would look occasionally to go to other places. This was all just, you know, us trying to figure out if we could get sort of a descent, a direct descent kind of approach to work. And I'm pretty convinced at this point that it sort of doesn't. And so I want to switch to more of just the open field search. And, you know, I guess we'll start out with the very slow version of this first, and then we'll go, you know, we'll start with the very slow version, and then we'll see what kind of optimizations we want to put on top of it. Now, it may be the case that we don't ever really care too much about optimizations, because remember, right now our routine is extremely slow for the reason that when it has to actually test a collision, it doesn't have a spatial partition with which to do that. Once you add the spatial partition, the checks will become about 8,000 times faster, right? Because rather than checking 8,000 entities, it's going to check like 3, right? So not 8,000 times faster, 2,000 times faster. So when you figure that into it, it may be the case that we don't care that much. But for large motion steps, I don't know how fast the fastest things will be allowed to move in this game, but for larger steps, it may still be the case that you don't really want to check all the voxels. You want to be more judicious about how you process them or whatever it is you're doing, right? So I do think we need to be sort of aware of that, and we'll have to think about how we want this to work a little bit, more carefully as we go. But I'm going to start with the stupidest possible version, and we'll sort of improve it as we go. So, like, first of all, let's re-enable this part of this routine. What we're going to do here is, rather than doing this inside the loop, we're going to do it outside the loop. And we're going to do some, yeah, I mean, this is going to be expensive, and I'm not going to care at first, right? So we're going to do it in the dumb way first, and then we're going to do it in a smarter way after that. The diagram test here, this is going to be a little bit different, so we're going to move this, and I'm going to put 2 diagrams in here, so we have one here and one here. Something like this. So this way we have a diagram for the initial voxel testing, and then we have a diagram for how we move through it, and we can kind of play with those separately. So here in the first collision voxel part of things, what I want to do is, again, sort of change the notion of how this is working exactly. You can see here that we have a to-p and a from-p for this voxel. And the problem that we're going to have here is we do want to bound this motion to some kind of a maximum motion. So there's going to be a little bit of that happening as well. But I'm going to probably do that in a different way than... I'm probably going to do that slightly differently, as you'll see in a second. But the first thing we need to decide here is what's the maximum footprint that we're willing to test for these voxels here, right? And for starters, we don't have to store, obviously, a B32 for that. We could store just a 8-bit value. And so what I may do here is just say, yeah, there's going to be like a Boolean for 8s, right? And the Boolean for 8s, I guess would just, yeah, we don't really need to do much else there. Would just be so that we don't use a huge footprint for storing this information. The voxel dimensions in this case, remember, we're trying, assuming we want to keep this relatively under control. How much space do we want to use for this sort of thing? If we were doing some kind of a 4K, like a thing that takes 4K to remember stuff, is not a particularly huge deal. So if we wanted to, we could do a 16 by 16 by 16, and then we have this voxel here that is stores its dimension, and this allows us to iterate over these and produce useful information here. We have a couple things that are difficult for us to deal with, right? Doing this interior part here, we probably want to delay, right? Because we only want to spend time looking at voxels that we actually need to look at. So we want to do something here, and we'll have to figure out what it actually is. And now I think about it, this B8 might not actually be what we want. We may actually need something more like a U8, where we do like actual testing, where we set it to 0, and then like 1 is you can be there and 2 is you can't, because we need to know whether we've tested particular areas or not, right? So there's that. Well, okay. You know what? Let me say that differently. Maybe, what if we want to preserve this? Maybe we don't have to do that. Maybe we just do a B8 here for tested, right? Where we say, hey, there's this this stuff is not really a voxdim anymore. This is just the local cell that you're in. And we just say whether we've tested this particular cell or not, so that when we look and say, should I try this location, we just don't try ones we've already been in, right? That to me seems better, because that way we can preserve things like testing for the field repulsion, which we needed to determine like what direction we were supposed to move in, and we you know, without the idea of like a way to push you out of things that are colliding, we would have trouble dealing with times when the game puts two things in interpenetrating positions, right? So I'm just trying to like figure out how I want to work with that, but that's one, you know, that seems like one useful way. So in here where we've got remembrance of the testing, I think I'm going to change the sort of meaning of these. So what I might do here is say, look, voxdim is going to be this other thing that's like the total dimension that the voxel takes. And then the individual cell testing here is just going to be, you know, this. It's just one cube always, right? And that way we kind of don't still have this old vestigial remain of a voxdim not actually meaning voxdim, which is just kind of something we backed into because of the way we're testing before. So if we have a thing in here where we define what the voxel dimensions are, now we can actually say like, okay, there's going to be like a thing in here that says whether or not we've actually tested the particular voxel that we're in. And we have like this concept of a location. We need to track now this stuff in a different way. So you can see here, like we've got this like best min corner, orig corner, and we do like, you know, this update best sort of thing. And that's not, I mean, the good news is that's not really going to be necessary anymore. Because what we can do here is we know that we're going to be searching through this space. And really what we want to do is, you know, the most straightforward way to think about the algorithm is imagine you test all the voxels and you know which of the cells you can possibly stay in, right? It's any cell that has at least one corner that's not colliding is a cell you could stand in, right? Well, move in. These things are floating, so they're not even standing, but you get the idea. You start out in one of those cells, and you can move to any cell that has some common vertex with you that is not colliding. So you could think of it as like a flood fill. Starting from there, you move out to every cell that you touch, adding it on to the stack every time, right? So what we really want to do here is say, okay, after we test this stuff, we probably want to change this, we probably want to change the way this works. I'm not even really sure why we are doing it this way. Since this sets all of the occupieds to false, it's always going to not do any of these, so I don't know why these are not just in the loop. I see why. Because basically all we wanted to do here was say, look, proceed as if you could move through anything, take the best point, but we're going to change where you're trying to get to, right? And that seems reasonable, I guess. So anyway, if we take a look at how this is going, right, what we want to do here is move. We want to keep a stack, right? And the stack is however many places we still need to try. So you can think about this as being the thing that tells us whether or not we can move into a space or not, because whether or not we've tested it. We would also need a thing that says which voxel index we're actually looking at. And if you think about how we're going to address this, we probably want to start thinking of it this way so that we can just use a single integer to refer to the point that we're actually using. So, we can just do something like this, like voxel stack, right? And, however many of these we want to actually be able to track. This is way more than we actually need, but it doesn't really matter. And then we'll have a voxel stack depth, right? And so what we want to do here is take the initial position that you're in, and we want to push that onto the voxel stack. And then from there, we want to test that one and add the things onto the stack that are like neighbors to it, right? So the first thing we would do here is we would do something like voxel stack depth equals something, right? We need a way to look like, so something like this, right? We have a position in the voxel, and we need to know what its index is for tracking purposes. So we need to be able to say, okay, produce a voxel stack value from some positional value. And it doesn't really look like I don't know that makes a tremendous amount of sense the way I've got it now. So I'm going to kind of think about this a slightly different way, but, there's going to be an initial voxel position kind of thing, right? Current voxel I. We'll do it like that. So we're starting on the stack. We push one on. Each time through this loop, right, we're going to basically say, like, okay, while the voxel stack depth is not 0, right, we're going to pull off one of these indexes. So we're going to do a voxel stack depth minus minus. And probably something like this. So we'll pull a voxel index off the stack. We will have to compute it now from this. So this voxel min corner cell dim thing, the voxel min corner will have to be determined from this. So it will basically be something that looks like this, right? Like some way to generate a minimum corner from an index that we store on the stack. And we could make this actually just store corners, but it would be more. And, maybe I should do that first. I don't know, because, it'd be less error prone. And then we convert to something that generates indexes separately. The problem is you have to go one way or the other, right? So I'm not sure that really matters much. But anyway. So when we come through here, I suppose what we would probably say is, all right, when we pull this off, the current voxel index value would also be an index into the tested array. So in other words, and we could double check that. But basically we would say, look, if we have not tested this value, then we do whatever it is we're going to do inside the voxel loop. But if not, we just don't, right? So we skip any of these that we've already tested because, you know, we don't need to test them. Okay, so assuming that we haven't tested it, then we'll basically say that we have. And then we'll go through and actually do the testing. So we produce the min corner. We test for the occupying, whatever, right? We then go, and this stuff now really doesn't have to happen, I don't think. So I'm gonna have to think. Rocket Bean. Rocket, come here. What are you doing over there? What are you doing? We've got an intransigent puss. We've got an intransigent puss. All right. So anyway, when we push these on the stack, I have to think it through, but I believe we will be able, like, I don't actually think we will need to do any additional work to make it track through the closest, starting with the things that are likely to be closest and ending with the things that are likely to be furthest. And I think the reason for that is that if you just look at this code right here, you should be able to just order, the order you push the voxels onto the stack should just, as long as you do them in the order from direction we're going to opposite direction we're going, as long as you push them in that order, you'll automatically check the things that go in the correct direction first, right? So I don't know that we really need too much more than that, but I could be wrong. So, you know, we'll see. So we don't really need update best anymore. Really all we need to do is to have each of the things. So we still want effectively this, right? It still is, exactly this series of things. It's just that instead of it being having a best on here, it's really just going to do pushes onto this stack, right? So this is really going to be like push voxel check or something, right? So really all we're doing here is push voxel check on each of these as we flood fill through the space of things to look at, and we're just going to let forcoder indent this wrong. If it does, oh no, it indented it correctly. That was weird. Oh wow, so basically like if you indent a block, forcoder indents it correctly, but if you indent a line, it doesn't. That's all right. I should update probably to the latest version of forcoder because my understanding was that got fixed, and I guess I can see why, because it looks like it wasn't actually broken. It's only when you indent a single line that it has that problem. So it's probably just a state bug or something, right? Because when you do the block, it doesn't screw it up. So yeah. So when we're doing this kind of flood fill, I think that these checks are probably not... I think that these checks are probably not the kinds of checks exactly that we want. The reason for that is I think what we want to do is just use an OR, right? So I think what we want to do here is say that, look, if you want to move from one cell to the other, if any vertex that they shared was if any vertex that they shared could have been moved through, then you can move through it. You know what I'm saying? So I think, these should really just be ors. Because that means that there was a place you could have stood in between the two cells, right? So I think it just means this, right? This is what's actually happening here. So if you look at how this push voxel check would work, you can see here that this is moving through. You got 1, 2, 3, 4, 5, 6, 7. This is testing 7 of the neighboring cells of the voxel. And, how many should there be ideally? It would be... So there's 9 at the top. 9 at the bottom is 18. And then the ones right around it, its own self doesn't count. So it's an additional 8. So it would be 26, right? Is how many you should be able to move into. Is that right? So this moves 1, 2, 3, 4, 5, 6, 7. It seems weirdly low. Because so 1, 2, 3, 4. This is one of those ones where I should probably just draw it out. So there's 4 on the top, 3 on the bottom is where the 7 comes from. So you'd add another 4. I guess that number checks out. Yeah, okay. I guess that number checks out. So yeah, so if we look at all of the possible motions here, and we excuse me. I guess, yeah. So what I'm thinking here is we probably just want to be able to check. So the triad opposite stuff, you can sort of see us try. We're switching to we switch each of these as we go. It's unclear whether we want to support moving in directions. I guess is all I'm saying. It's unclear that we want to support moving in directions that are literally directly away from where we're going. That might not be something we actually want it to do, and I don't know. But if you look at how many of these pushes we're doing here, I'm trying to think if there's any way to do this in a more efficient way. Because you're just going to end up doing a lot of unnecessary checking as you step through here, right? You really don't want to have to do quite so many checks as you flood fill. You know what? So I think here's the thing. Since we are now searching the space, I guess we don't actually need to do this. We can literally just check up, down, left, just the 6 main directions, right? Yeah. So we can literally just check the 6 main directions, because if you can move, if you could have moved through a corner, you will now detect that case by moving first into one, by moving around the corner by cubes, because each one of them is connected by 1 vertex. So I think that's all we actually need, and that'll be much better. So basically, this is all we actually need. Just the 2 versions of this. I should first change that to best. It's actually going to be something like stack, right? So yeah, it's really just pushing these on. And in fact, we can have the compiler do this for us, hopefully. Famous last words. By just doing like a negation, right? I don't know if it'll actually do this for us or not, but you know. So hopefully we can get the compiler to do this for us. It's always annoying to even have to think about that. It's yet another reason why, like, you should just be able to have had in C just like that, and it would just do it. Like, it's not an option. Like, you don't get to decide whether you unroll this loop. Like, you will unroll the loop. I think Clang has like a directive for that you can pass, but it should have just been in the language. So anyway, in here where we do these push checks, then all we're going to do is say, and in fact, I suppose I could do something like this. And so that way we can just do like, oh yeah, we'll test, we'll test the directions that are, but because we want it to kind of be, yes, you really want it to be this, where you test the positive direction first, right? And the negative direction second. Like, that's really what we want, right? And so, in here where we do these sides, then it's just like, oh, well, you know what? No, let's just do this. Original way was fine. Really, we just want this to be... I feel like I'm getting too fancy. I was trying to figure out a way to write that, fancier, but I think I'm just not gonna. So in here, we maybe just do something like this. And just look it up directly. And that just seems more sane to me. So in here we have like the side Z, whatever nonsense. So in here we just say, look, the side Z equals side.z or whatever. And we just say either use it or don't, depending on which one you're doing. So if you're on 0, you use the original. If you're on 1, you use the negative. And that's all there is, And this is just to get the compiler to generate these checks for us. And so then we don't need any of this. We just say, okay, if I suppose this is going to be easier said than done, but yeah, because now that I think about it, like we got a bit of a brain bender if we want to actually have the compiler generate this for us. But for each of these, we're going to want to negate, yeah, okay, never mind. Like, if we were really going to do this, we could actually try to make that generate out of the iteration. But then I was like, that's a bridge too far. So what we've actually got is this, where we want to test each of these, where we say, okay, like, here's our if statement, assuming that this passes. Does this mean I can get this indented? Yeah, that's really weird. Okay. So here's our here's our actual checks. And for each of these, we're just going to do the manual check and negate each one. And since we're only going to talk about 2 of these, I don't even know why I bothered with these extra ones, because we can just actually flip them all, because we're multiplying the loop by 3, right, by having the interior. So really we just need one, like, flip check. And we test the negative direction when we do the flip check. So after testing each of those, we know that we would push this particular voxel, you know, onto the stack. So using code similar to that. And we would also need some way of preventing the stack from growing, like, too large. So we would need an assertion at some point here that's like, hey, right? And we need to do a computation where we determine, like, what is the largest, you know, what's the largest that this thing can it practically be, so that we make sure that the stack is large enough to handle the largest possible search, given the, you know, it'll be some proportion of the total. It would probably be like 16 times 16 times 4 would be my guess. So it'd probably be like 1024 or something like that, honestly, which would be really bad, right? Which is what, you know, maybe this is arguably, like, too large, and it should be smaller. That's totally, that's a totally plausible. It might actually be times 6 too. Yeah, I mean, it's quite large, is the problem. But anyway. The reason I say that is because in theory, if you're flood filling the space, you know, you're never going to actually have to push on everything that's in the volume, but you would have to push on something proportional to the total surface area of the volume, right? And so if you imagine a 16 by 16 by 16 cube, the total surface area is going to be 16 times 16, roughly, times 6, one for each face. And it's not counting the shared pieces around, but, you know. So, yeah, that's quite a bit. Which is why maybe this is a bit much. You know what I'm saying? But, again, you know, we'll cross that bridge when we come to it. Or we won't. So, when we actually do these tests to figure out what we're pushing on, then we... Why is that an illegal size of operand? Oh. So I think now mostly the problem we have is we don't have the way to actually produce these voxel indexes, but this is roughly what the routine would look like each time through. And we need also to produce the closest point here for each of these. So this part is going to be an interesting question depending on how accurate of a guess we want. If we want a extremely accurate guess, we would need to use some kind of a root find. So we would call refine voxel placement on each cell to see what the closest point would be. I don't think we actually want to do that. We probably only want to do refine voxel placement when we finish. So that'll be, you know, this this will be sort of a different, a different point. So we'll probably just call get closest point inbox conservative, right? And honestly, so this is not really very good either. So I don't think this refinement step would actually work anymore. We would need to have some kind of an understanding of like which cell we came from, in order to do it that way. So how we actually do the refinement step at the end is more of an open question. And probably has to take into account that voxel information. So we're going to have to do some fancier footwork in here for sure. Yeah. So the problem here again, is like the pushing this stuff on the voxel. We need to determine what these new voxel points are. We probably also need to do some testing here to determine whether or not we can actually put anything in here, because we're going to have problems of stepping outside the voxel. So when we push things in, they would have to get rejected in that way, right? So encoding these into a 32-bit number is pretty trivial. I don't know that we really need to do it. I could just use a v3s to start with and have the x, y, and the z just stored in there. And that might be a better way to go at first, just to make sure we don't add additional things, meaning something like this would be a better thing to do. Yeah. And, we don't really have anything like this currently, but, this is the kind of thing that I would see doing like something like this because I think we're just going to have too much stuff to track here. So I'm going to go ahead and say something like this. And this way I can use helper functions too. Right? And you can create one of these voxel stacks and it will, we can make some helper functions, right? So we can, and, this will also prevent us from pushing things on. It'll get rid of this, basically, right? So this call we won't need to do anymore. We can just have the the thing that does the push does the check, which is better, right? So we can do push voxel stack. We pass in the index. And here we can do a bunch of testing on the index where we say, for now, I guess I can even just do this. Where we say the depth will not get pushed unless all of the checks passed first. So basically, like, I don't know if we've got an actual... So we have a voxel grid. You know, we could actually just use the voxel grid that we have. So like this, right? We could actually do that, and the cell count we would just set to be, you know, whatever this is. That seems plausible, vaguely. Yeah. I could see that being a thing. So we could do something like that, and then in here we would just say, look, if it's in the bounds, then that's great. We also need to assert that we've got room, because, like I said, I don't know. And then we will push it. So in here, we're basically saying, all right, we've got this voxel stack. It's going to use the voxel grid thing so that we can use that for testing. We will check to see whether it's in the grid. And then, assuming that it's in bounds, that means we can check for tested, right? So we can say if we haven't already pushed this on, right? And what I might do is change this to, like, pushed, so that we just say, look, as soon as you push, we remember that. So we will only let you push something on if that something has never been pushed on before. So that seems like a good push voxel stack, right? That will work okay. And that way we just, like, throw things on there, and we know that it's only going to add things that we haven't tested yet. And that way in here, we just do... So this is... It's not really negative, right? Because it's 0 or 1. So it's really just not... Right? If it was 0, it becomes 1. If it was 1, it becomes 0. As we add through here. Right? So at some point here, we've got like a current voxel I, and here we go like pop voxel stack. Right? None of this happens anymore. So there's going to be the pop voxel stack call, and that will get us whatever our, you know, our voxel corner is out of here. And so then in order to push these, it's just going to be like for each of those sides, We should probably push Z on last as well. For each of these sides, we want to push on the correct step, whichever direction that is, you know. And it's going to be like 0 or 1 has to translate to like 0 to like -1 or 1. So when we look at what voxel has to get pushed on here, it's like, you know, there's a next voxel I, right? And it's current voxel I. But then whichever one of these we're stepping along, so like in this case X, has to be like added to by either 1 or -1. So if the direction we were going here, if it was 0, then we need to go backwards. If it was 1, we need to go forwards, right? What is it, Booba? Oh, how you doing? Did you need tummy kisses? You need tummy kisses, yes you do. Because you're a big tiny tiger. You're just a tiny tiger at the end of the day. The puss arrive. Why did the Twitch chat go away? Nobody knows. This is the puss. Yes, so the reason that sphere collision geometries help sliding around corners with search and P is because the points that will be included in the movement are different, right? So if you imagine the corner, if you're in a voxel search and you are knocking out points using a radius, like a sphere that's rounded, the corners will tend to have voxels you can move around, whereas if it's hard edge, they won't. You know what I mean? But in the case of where we're switching to the full search and not the partial search like we did before, it probably won't matter. Because now we're actually going to search wide, so the search and P should be able to find that motion if you widen the search space enough, right? And I don't know what that'll end up looking like. But yeah, in theory, we could turn off spheres if the search space is wide enough, and it would find it without, you don't need the sphere anymore, right? It would still find it. The motion would be like, it would be an L-shaped motion instead of a curved motion, but it would still find it. Okay, so here's us moving around the voxel. Oops. Around the voxel. And think that's all we need for that part of the code. Yeah. We need the pop function. And there's a couple different ways we could do this. My guess is it would maybe make... So... There's one other thing that we need to do as an optimization. We don't have to do it yet. So there's something that we have to also take a look at here, which is that at some point you know you can terminate this routine because you've searched all of the places that you could have put that could have generated a closer point. And that's kind of a tough one to think through. So that's going to be another thing, right? Because, you know, if you've already tested all of the space around immediately surrounding the destination point, like where you're trying to go, then you don't really need to test any more cubes, right? If you've already tested all of them and found the closest point among that set of cubes, and you know you could go there, you don't need to test anything that's like further away from that anymore because there's no way to get a better result. So we need to kind of like work through that part as well, but we're, you know, one step at a time, right? All right, so let's see. Okay, so we're going to call this cell I, and we're going to call this depth, just so it's clear what's going on here. We're going to push one of these on each time. Then we're going to take the cell I here. And do the pop. We're also going to do an assertion that the stack depth is greater than 0. And I'm going to have a function called stack not empty, right? And that's going to be this. All right. So we can then do our loop. Our loop is just while the stack is not empty. And we'll have a push voxel stack here that does a push onto the stack with the initial voxel I. And because we need to do a conditional push here, I'm going to have like a condition that you tack on. And so we'll just see like if the condition is true that you pass in, because, you know, well, okay, so we have the if statement here. Yeah, maybe this if statement just goes on the end. Right? I think I liked that better. Well, you know, but then again, why make it more complicated? Since I already did that, I guess that's fine. Okay, so I think that's everything there. So we push something onto the stack initially. We need to compute what that actually is, but that's fine. We loop while the stack has something on it. We pop stuff off of the stack to as we go, right? And we actually know now, because we have one of these, we can produce the point for like the center or the minimum or whatever, like cell, you know, get cell bounds or whatever. We can produce that directly. So I think we can just do get cell bounds now, where we do like stack grid, and then the index. So I think that just works. Right off the bat now, because we can just use that code we already had. We have this stuff is irrelevant now, and we've got some other things we've got to look at as we go. And so, yeah, like, we have the problem with embedding, and I don't really know what we want to do about that. You can see here we've got sort of this notion that, like, if you are embedded in this particular voxel, then there's a question of, like, how do you get out of it, right? And my assumption here is that that sort of wants to be something that we do, like I'm not sure how what the best way is to handle embedding in here, you know. Yeah, it's a tough call. I'm gonna leave it the way it is now. I'm just not entirely sure, like, exactly how, yeah, how we want to do that. Anyway, so really, mostly what we're looking at here is this. The get closest point in box conservative I think will just work. So I think this is almost the entire loop. All we really need to do now is just say, all right, this is just going to track the best voxel. And then the only thing I'm not clear about, because you can see sort of how this is going to work, right? So we don't need, like none of this stuff is a thing anymore. Right? Like, that's not... We don't actually need any of that. So that goes away. And we don't need any of this anymore either. So the only question now is, first of all, we have to be able to produce the correct index for the starting point in the voxel and the voxel bounds. So we got to do that as a separate thing. We'll deal with that in a second. But then we've got this problem of like, okay, so in terms of like in terms of how we like accept motion here, we need to start off by saying that there is like a best cell that we found. And presumably that's like, you know, initialized to like whatever the starting cell is. Like the best cell is just wherever we are right now, if we haven't found anything better. And then there's probably a best distance, which is like whatever that was. So this cell's closest point like is going to be the best one. Actually, no. You know what? I think that's just going to be this. So the reason for that is if we start out embedded, we don't want to consider that to be a legitimate place to put the player. So we're going to ignore that. So then what I'd say is, all right, we check this distance squared, right? And this is the best distance squared probably too. We figure out what we think that is by testing the cell against it, right? So the 2p thing, like where we're actually going, is probably more like this. And then we're going to see how far away we get when we try to place ourselves inside this box as close to that point as possible. What would the closest possible point be? We use that distance squared here, which is only an approximation because we don't actually know exactly where we could have placed it. And then assuming that this distance is better, then we would accept that move. So this best cell I here, right? Best cell I is going to be equal to the current voxel I. Probably should just be best cell. Okay, so we step through the cells. We try to track which one of them is going to be best. So this is how we do that. We test all of the neighboring voxels by pushing them onto the stack, and we walk the stack as we go. As it is currently, this will always test the entire voxel, which will be very slow. But again, we're just starting there. The minimum corner equals best min corner thing is not a thing anymore. That will come from the stack walk. The best cell, we can now do the get cell bounds call here. So we can just say like the best cell is generated this way. And I don't know what best cell is used for. Looks like it's up here. So it's really the starting cell. So that doesn't really make a whole lot of sense there. So I'm gonna actually change the way that works and just make this be something that looks like that. Yeah. So we have a problem here, which is that this is not really very good. The reason it's not very good is because it presupposes that you moved along the line from the starting point to the final point. And we don't really have any reason to believe that that's what you actually did. So that line as a probe is not useful. What would be useful, however, is not clear. You kind of need to know like how you got here. So that's a tough one. So I'm going to leave it like this for now, but so, you know, like I said, I really just don't know. If you came in like from the side to this cell, which is allowed now, putting yourself at the point where like you would hit from the front P might be like really wrong, you know? And so, you know, we may want to try and do better than that. So, yeah. I think we're almost done with this part. I don't know why this is here. All right. So this is still like very wasteful. We could cache these checks. Cache these checks. Is there... Right? I mean, I don't know, like, if there's a saying along those lines from Top Gun. Maybe. Anyone? Anyway, so that all seems fine. So let's work on the startup. So here we go ahead and we produce like some nonsense or whatever. If you assume that that's the minimum corner for this voxel, and we produce the direction constant, then that's really all you need to create the voxel stack. So if you then create the voxel stack, the grid which is here, Um, we want to make by setting the cell count and the cell dimension. So we know what the cell dimension is because it's right here. And we know what the cell count is because it's like this thing. And so really the question that we then have is, what's the minimum corner? Now, this is obviously the minimum corner because it's called minimum corner. But what we'll actually find if we try to use that is, no, it's not. What we meant by minimum corner here is it's the minimum corner of the cell that you start in. But because we don't actually look and see which direction you're going, it may actually be that any of these that were negative would have moved you backward, right? So what we actually need to do here to produce the minimum corner is we need to actually, like, go in that direction for as many steps as the voxel goes, and then we bound it there, right? So we need to do like a corner A, corner B. So this is really the voxel starting corner, is the way to think about it. And we then need to add the cell dim times the direction, right? So we know we're going to start here and we're going to go, we're going to go that many steps at maximum, like 16 steps at maximum in whatever direction we're trying to go, in this solve, right? And so after that, the voxel min corner is like the element minimum. Do we have an element minimum? I guess we do or don't. Nobody knows. How many min functions do we have? So it's just the element minimum of those two, right? So it's this. That's the minimum corner. Because this is the furthest we could go along the direction. Is there no... How do you convert this? Surely there's a way to convert this, right? It's right there. Oh. That was dumb. It was already a V3. So that should just work, right? Then we have the question of, like, what is the initial cell location? But now that we actually have a voxel grid, we should be able to just use the functions there to get the voxel index for whatever the placement of the person is, right? So the initial cell index is just whatever the voxel grid now says it is, right? The starting location we can just get, and use our helper functions for that. Okay, so that's compiling now, and I think we're out of time. We'll debug it next weekend, but that's the start of the full search routine, and mostly what it will be right now is very slow. Once we remove the bugs from it, it'll be very slow because it's going to test literally 4,096 cells every time, because it never will like early out, right? So it's going to test them all, even the ones that are obviously very bad and could not possibly be helpful. So that part we have to fix. Also, we don't need, the other thing we should put here is like, I think the other thing we should do here is we want to change the voxel to only be the size that it actually needs to be to encompass the size of the move. And then we can clamp that to be less, but, you know, if it was too big. But we don't want to create things that are larger for no reason, right? Which is the other problem we were doing here, if that makes sense. All right, let's do some Q&A. Maybe I should actually write that code in here instead of Q&A just real quick, because it's not much code. So if you imagine this is the actual span. So this is the span that the voxel... If the voxel was going to span the entire thing, it would be this. So... if we take the minimum of these two, and then we take the maximum of these two, and then we do the floor, right? You can see the voxel starting corner here part where we do the like floor to get these to the right locations. So in order to find that span, you know, it's weird that we don't have this already. You know what I mean? But we don't. So that's how you know much space we would actually need. Excuse me. To encompass. Well, actually, you know what? Maybe I don't even really need to do that. So this, this right here would probably be sufficient, right? So when we produce this minimum corner, we can also produce the maximum corner of those two. And then we can produce the total expected span. By taking the difference between those two and dividing by the cell dimension, right? So that's the optimal span. When we then go to make the voxel grid, we can just say that there is a max voxel span. And when we then create the actual dim, we can just say that the voxel dim is just the optimal dim, right? clamped against the maximum dim. That's it, right? So we can just say, look, whichever one of these is smallest is the one you use. You know what I'm saying? So I think that's right. This is a little bit tricky here because that's good. So this is a little bit nasty because looks like we have floor but not ceiling, right? Which is weird. But you can see here, like, we've got this issue where we're dividing by the cell dim. And we want to make sure that we include the largest part, like the furthest part. So we want to ceiling that value to get what the actual index would be there. And it's not going to do that, right? So, I don't know. I mean, it's probably this at that point, which is not really what you want to do. But I mean, it seems like that's roughly what you're going to have to do. What's the problem here? V3S. Is there no way to, like, how do I produce an actual dimension value from these? Like, there has to be a way to floor this to... Yeah. So it looks like this one, yeah, doesn't quite... So, you know, we could still use the other way of doing the minimum. Like, there's no min for V3S's here, which kind of sucks. Because we would like to be able to do that. Maybe we'll do this. Which is not great, but at least it's thing. So... Don't ask me why we have two different words for that, but we do. And it looks like we use the phrase voxel dim here. Of course, that doesn't really matter, so maybe we'll just put that over here. Okay. So I think that's all right. And again, all right. So now I will really, for reals, go to the Q&A. But I just wanted to throw that in there because I think we want to do that, so that if you're just talking about a little tiny motion, you're not going to search this large grid for no reason. Or you're not even going to initialize it to a large grid for no reason. Seems also good. Does your in-house editor cache tokens for a buffer and keep them around? I have my incremental tokenization, but the memory overhead is pretty gross and unnecessary. I'm thinking of just fully caching the states, like whether you're in a block comment or not, and then caching only n lines of tokens with LRU eviction or something. I have a suspicion I'm just overcomplicating things. Pushfox has a typo. Let me look at that. I'll answer that question, but thank you. I guess what I would say about what you're talking about with the tokens is, what are you trying to do? Like, it's important to try and think about what you're actually doing and what problem you're trying to solve, because the answer to what you do usually is very dependent on what problem you're trying to solve. So if you are talking about small files, so like the size of the files that we use on like Handmade Hero, then honestly, like just a very fast parser that you run every time the user hits a key would be fine, right? And storing a bunch of state is probably actually going to end up costing more than just running it, because, you know, like if you look at the size of the CPP files on here, they're like, you know, like 64K is like the size of a file, you know? And so if you're talking about files that are 64K, I mean, you don't want to do anything incremental. You just want to parse it from start to finish as fast as you can every time. When the user hits a key, you just parse it again, right? So at some point, if you want to handle large files, there is a crossover where now it becomes beneficial for you to do caching, where you don't want to reparse the entire file. My suspicion, and I could be wrong about this, but my suspicion is that when you want to do that, you probably still want to do parsing of entire blocks at once with no caching. And so mostly what you probably want to do, I think, is sort of what you said, but I'm not sure of exactly what you meant. But you probably just want to cache, okay, what state affects the, you know, save the parser state at various sequence points throughout the file, and you just restart from there when you touch something that's inside the file, right? In general, I would say all of this is a giant waste of time. Text parsing is dumb. It shouldn't be done anymore. If you want to look at something that's actually doing things the way it should be done, you probably want to look at something more like Dion, right? That Ryan and Alan are doing. Parsing text is stupid. I don't know why it's still happening. There shouldn't be such a thing as a text editor anymore. The fact that there is just a good example of just exactly how dumb this entire process is. So What do you think about using search and P in games with movement that should feel physically correct, like gravity, jumping, etc.? Is there an extension of your work on The Witness that would work well there, or would you go with a classical approach like GJK or NPR? So there's really... those are like conflating two separate things, I guess is what I would say. So search in P doesn't have anything to do with how you're doing collision detection at all, right? It's how you are using the results of your collision detection. So search in P can still be used with GJK, right? You just use a GJK solver to determine to ask the questions about the placement of your thing. So like even inside the Handmade Hero one, which is search in P right now, you can see that's exactly how it works. You call a function called collides at P, and this is unrelated to the search in P, right? It's just a thing that does a collision detection path. You could put GJK right here, and it would change nothing about the outer routine, right? So there really isn't a difference between search in P and search in T in terms of what collision detectors you might use to produce the output. So search in P just works fine, even with physical stuff. It's fine. There really isn't any difference between the two. They're just search in P is more expensive but more robust, right? So it's really more about expense than it is about. It's more about search in P is more expensive to be more reliable. It doesn't really change what you can and can't do. It changes the cost. So search in T is much less expensive because you're only sampling one route. And the cost is in robustness because you have no idea whether that path is reversible. It could have just been numerical luck that you were able to do it, and you will have no idea if you can do it in reverse. So the player can just get stuck, and that's it, right? So search in P and search in T don't really have different they aren't changing what the player could do, or how you're testing what the player can do. They just change how you are looking at the results of that information and deciding yes or no, you know? And you can't... I mean, maybe if I started working more on search in P and spent another year just like looking at that as a technique, I would figure out ways of making it be as cheap or close to as cheap as search in T, and then it's just like, yeah, you could always just use it. But really, the more important part of that to look at, it has nothing to do with what kind of game you're making or what you're trying to enable. It's just cost. So the collision detector on The Witness is expensive. You couldn't just use it for 1,000 entities all moving around at once, right? So you have to take that cost into account and say, can we afford it on this particular game? Is it important in this particular game? If it's not important, we're just wasting time, right? Yeah, so the sandwich maker, like, I would say if you're trying to open really large files, then you're really just going to have to deal with caching parser state. I mean, there really isn't so one of the reasons text files, there are so many reasons text files are stupid and no one should be using them for anything, even though everyone is using them for everything. One of the reasons is that they're a giant dependency chain. They start with the first character, the next character is dependent on that character, and every character thereafter is dependent on all previous characters, right? It's the dumbest frickin' possible thing you could ever have created, and nobody should ever have used them. The only reason they were used, even at the beginning, was because computers were probably too simple to contemplate using anything else. Since like 1990, we should not have been using text files. They're absolutely stupid, and the fact that we continue to build the backbone of computing on text files is absurd. It's absolutely ridiculous. So I guess I would just say, like, the concept of text files for storing things that are not a giant series of linearly dependent. If you're not storing one giant single dependency chain in a text file, then you picked the wrong file format, period. And that's really the end of it. There's nothing else to say. So people can have fun all day long creating their new fast text editors or whatever the heck. They're still going to suck. As long as you're editing a text file, it's going to suck. And that's the end. That's beginning, middle, and end of the story. All right. Oh, is John streaming today? I think maybe what we will do is raid John then. Let's raid John. Nothing low. All right, I'm going to close this out. Don't store text. It's not how would one store text. It's don't store text. It's not text. Right? Look at this. This is not text. These are individual functions. They don't depend on each other, right? So don't store them as if they are, as a text file is a one-dimensional dependency chain that goes in a direction, right? These two things are completely independent. They should not be stored as if they are dependent on each other. This doesn't go after this, right? It's just dumb. Like all of these languages, text files, parsers, compilers, they are all stupid. It's all a bad idea that people keep doing for, I don't know what the reason is. I don't know what it is. They have no imagination. They haven't thought about it. They are too much of a slave to the current ecosystem to see what's actually important. They don't want to actually do the work of coming up with a new file format. I don't know. I have no idea what it is, right? But like the notion that people keep using this is just crazy. No, books aren't text either. They're not. Like the fact that you can take a book and open it up to an arbitrary page and start reading means that it is not a serial dependency, right? Nobody forces you to read chapter 1 of a book before chapter 2. So the concept that you would store it as just a giant linear dependency chain doesn't make any sense. You would store it broken down by first chapter, then paragraph, then sentence, then word, then letter, right? So like, none of this makes sense. There's almost nothing humans have ever created that it makes sense to store as literally a sequence of individual letters with no idea of how they go together. It is absolutely ridiculous. There are no things I can think of that we've ever made where that is a reasonable file format. It makes no sense, right? You would never store anything that way on purpose. Not books, not code, not web pages. None of the stuff that we currently store as text is textual in that way, in the way that we define a text file format. No, compression makes it worse. Compression means that now not only do you not have any idea what any of the characters are, but you can't even ask what the characters are without knowing what all the previous characters are. So compressing a text file is like doubling down on sucking. Now you're sucking even harder than you were sucking previously. The alternative to text is actually store the thing you're storing, right? So if you're trying to store code, store a thing that's like, here is a list of functions. Inside each function, here is a list of scopes. Inside each scope, here's a list of statements, right? Like, you store the thing in the format that it actually is. Like, think of it this way. Nobody stores anything that you actually need to operate on in this format. Like, if you go look at, like, how, pick anything you want, how Google stores your email or something, right? They may store the body of the email text as text because that's what email was stupidly defined to be. But the actual structure of, like, what's in which mailbox and what it is, it's a database, right? It's a thing that actually has, like, indexes over actual tables that say what the crap is. You know what I'm saying? So you always have... Data should be organized in the structure that it actually is, because otherwise you get the problems, all the problems that you're currently talking about, which is that in order to display, like, there will never be a text file that can display files quickly. Ever. In the history of mankind, it will never be written. The reason for that is I can always pick a problem that makes it basically impossible. Okay, here's a 1 terabyte text file, and I would like to see the syntax highlighted version of the last line. It's not possible, right? You would literally have to load and parse the entire 1 terabyte source code file to determine what the highlighting is on the last line. It's a stupid idea, right? The actual work necessary to produce the correct answer there is very simple, because code is actually not that complicated when you get right down to it. It was probably the start of a function just a few lines before it. So you probably only need to look at a few things to know what the syntax highlighting would be. But you'd never know that, because that 1 terabyte text file could have pound defines in it or who knows what, right? All this other stuff. Because the way we've defined storing the code is just broken. It doesn't map to the storage format, and the thing don't work together. Right? They don't work together. So just stop doing that. store code in a database and store it based on what it actually is. Yeah, I mean, an example of an interim step would be a C++ file where you just have functions are each stored separately. And that way, at least in order to create a pathological scenario, you would have to create a function that was like a terabyte long, which is absurd because the compiler won't be able to handle it, right? So at that point, you're pretty much okay. You know? I mean, you should still go further than that and actually just have the code saved as an AST because that's what the parser is actually going to do. Why bother having that step, right? So that's all. Yeah, if you were going to have things like pound defines, right, then they're going to be in the database as a specific thing, right? And they're going to have like regions to which they apply. So the way that you would parse code is you go, okay, this is the code block that I'm asked to look at, right? I look up into the pound define table to see which pound defines are active within this block, and I apply them. And then I display the text, right? So JSON is not great, but it's not as bad as like C or something, right? Because it doesn't have any ability. Like, you can syntax highlight JSON more easily. It's still bad though. Like, even just knowing whether or not you're inside a quote requires parsing from the beginning of the file. Right? Because it's a parity thing. Unless I'm missing something. I'm pretty sure that's right. But there's a lot of reasons JSON's a bad format. I mean, they did some things right and some things wrong, I guess is what I would say. For a text format, it's not that bad. But it's still text, which is generally bad. I'm not sure you would need, like, specific software, though. If we had just moved to ASTs to begin with, you would probably just have generic AST editors, where, like, the definition of a language is you put in the AST node types, right? And then files are just those. You know what I'm saying? And then you wouldn't even have parsers anymore. Compilers would just take AST files, right? And that'd be that. I should get the new remedy, you're right. There's fixes in there that I actually asked for myself. So I'm looking forward to it. The new remedy has a lot of good stuff. So I wholeheartedly agree. I'm on 3.5. I think there's a 3.6 that just came out. I want to say. Yeah. So yes, I will go download it. I'm not logged into itch on this machine. But yeah, 3.6 has a lot of good stuff. I haven't downloaded it yet. I need to download it. I need to put it on my work machine as well. Uh-oh. Remedy 3.6 is pretty crashy for you, Sandwich Maker. That's a bad sign. We should report him though, because like I definitely want to be able to use 3.6. So if it's crashy, we should report him. Right. Are there any editors or programming languages that don't use text and can highlight gigabyte files currently? Well, I don't know that there's any programming languages that don't use text. At all. So ignore the gigabyte file part. I don't think there are any. Maybe there are. But like I don't know. As for editors that can highlight a gigabyte file, well, I guess I don't know what you mean by gigabyte, but like sure, in terms of if you pick some other kind, if something that actually uses non-text, I mean, you can load multi-gigabyte files in ZBrush, right? And it just works. So I'm not sure really what you mean, but what happened to Rad Game Tools? Did Epic buy the company? Yes, Epic bought them. As you probably know, Epic Games has insane amounts of money now because Fortnite is so successful. So they wanted to, well, not they wanted to. They have been acquiring lots of game technology companies. You can go look at all their acquisitions. There's several. And Rad was one of the companies they wanted to acquire for game technology. So along with a bunch of other game companies, game technology companies, they are now rolled into Epic, and you know their tech is part of Unreal Engine now. If I still worked at Rad, would I get a massive bag of cash? Possibly. I don't know. I think so. I mean, it probably depends on, you know, how long you'd been at Rad and stuff like that. I mean, I don't know. I would assume that people got paid out quite differently depending on, you know, what they were doing for the company, but you know, I'm sure you would get a good payout. Yeah, it's just like any other acquisition, right? I mean, you get a bunch of money for an acquisition, usually, especially one of these, which is, you know, they want the developers too, so they're you know they're presumably they want to give developers like payouts from Epic that will, you know, if they stay for 5 years, they get money, that kind of stuff, right? Because you don't want everyone to leave. So usually when you're talking about acquisitions where you care about the people who are actually working there because you want them to come work on your tech, you know, I don't know the specifics of the way the compensation was for this particular deal, and I'm sure I couldn't talk about it even if I did, right? But they tend to want to pay people out over a few years so that they don't leave. I mean, what you know, you want them to be encouraged to like go contribute to Epic, you know, after they're acquired. You don't want people to just be like, I'm out of here, right? So, in other acquisitions, that may not necessarily be the case, right? You can imagine some cases where you've got acquisitions where they, RAD is a small number of very talented programmers, right? So when you acquire them, you want to bring all of those people on and put them onto things that are valuable to you. If you acquire a company that's just kind of whatever crap, right? And you don't really care that much, then those payouts are going to be like more about certain maybe key individuals, but you're not going to go out of your way to like be paying off random people in like the accounting department or whatever that you don't really care about. You know what I mean? So I think in the case of RAD, I would assume that most people, depending, on how long they'd been there maybe, and how crucial they had been, were probably getting different amounts of payout. But I imagine everyone got something because there aren't that many people at RAD, and they're all people that presumably you wanted to keep because they were a very select group of programmers. They're not just random people. And a lot of them are people who you probably, would find something important on Fortnite or Unreal Engine or whatever. There'd be stuff that you'd want them to go do. You don't want them to leave and go somewhere else, right? How's still a platform for SVG progressing? It's pretty good. It's harder than I would like because I had hoped that I wouldn't have to deal with payment processing stuff much. But having looked through the payment processing stuff, they are just very untrustworthy. Like, Stripe and PayPal and such, they're just very untrustworthy companies. They do not provide you with any guarantees that they will actually continue to process your payments. And so it would be a much easier problem if you could just use a single payment processor and trust that company, but you really can't. And so having to do the part where you assume that at any time one of your payment processors or a payment processor will just cut you off, which as far as I can tell is the only sane way to do business currently, because payment processors are the least trustworthy companies in the world that I can find. Like, I don't know of any kind of company short of like drug cartel that is less trustworthy than payment processor. It's like drug cartel, payment processor, other, right? And so because of that, you're in this problem of you have a service you have to rely on, which is payment processing, and you then have to take what is a service that must be reliable and write the part of your code that works with that and the infrastructure to assume it is unreliable. So you have to take something that has to be reliable and write it based on unreliable services. So it basically introduces an entire fault-tolerant engineering problem on that layer, right? And so I really just don't know. It's the same story over and over again, right? It's a hard problem for no reason other than the world is mostly made up of people who have no idea what they're doing and don't care, right? Like, the notion that payment processors can stop working with you because they don't like you or because the government doesn't like you is so bad for society. It's just nuts, right? What? John, no, you can't raid me. I'm done. I'm leaving. We were going to raid you. This is not acceptable. Oh, dude. You guys freaking asked me about the payment processing thing. and you got me on the stream just long enough that John was able to raid us instead of us raiding John. I blame all of you for that. John was just saying on the stream the other day that he hasn't done a lot of modern high thread count multi-thread programming, and this is what happens. Right? This is what happens when you transfer, you now are blocking on a thread that itself was about to go to sleep, right? Look what you did. You've ruined everything. Now the entire internet will deadlock and everyone will have to stop using the internet. So anyway, I don't really have much else to say about that other than what I said before. So the payment processing is a huge problem. It is by far the most so let me put it this way. If you want to write your own e-commerce server and you know that the payment processor is a trustworthy company, it is not very hard. Like you shouldn't be a novice because, you should never be a novice if you're writing something real anyway. You should, get good first or whatever. But it's not like a large engineering problem to write an e-commerce server if the payment processor is trustworthy. It's fairly straightforward, and really it depends on the API of the payment processor that you select how easy, but it might be embarrassingly easy. It can be an extremely thin layer over the top of the payment processor, especially if they allow user provided data queries of some kind. You can almost just use the payment processor as the database. There's really not much to do if the payment processor is reliable. If the payment processor is unreliable, which is true. So currently there are no reliable payment processors as far as I know. So if you assume that the payment processor is unreliable, now you're basically writing a complete fault-tolerant distributed system. So you've gone from easy problem to, serious engineering problem. And that is just it's literally that difference. So if there was a reliable payment processor who you could actually count on, you would have a very easy time. That doesn't exist, so now you're basically just doing the full work. And that's all there is. How do you test your code against an unreliable payment processor? Well, I mean, you just have to... So if you assume that payment processors are unreliable, they can go down at any time, they can just cut you off, right? And you can lose access to whatever was over there. What that means is that any time that something happens with a payment processor, your system has to also know what the result should have been, right? So you have to know whether someone previously had paid for something and was in good standing. You need to track all that yourself, right? And you have to track it in a fault-tolerant way. You can't lose that data, right? So it has to be stored redundantly. You have to have good ways of synchronizing it and knowing if things are out of sync and all that stuff. So pretty much testing against an unreliable payment processor, it's really not so much that you're testing against an unreliable payment processor, so much as you have to have all of the stuff that the payment processor could have possibly done yourself, do it yourself. And when you actually go to issue payment processing requests, you have to just assume that they might come back that you've been cut off. And you have to switch to a different one. And your system just has to be able to handle that, right? At any time. You have to be able to just assume that Stripe stopped processing your payments, so you're going to have to switch to PayPal now. Or PayPal stopped processing your payments, you're going to have to switch to Fat Merchant, or whatever the heck, right? So you're just going to have to assume, right, that at any time your payment processor may shut you off, and you basically need to be your own payment processor right up to the point where you actually run the credit card, so that at any time you can just switch to anybody. And that's a much, much harder problem. Yeah. So yeah, like cryptocurrency, the problem with cryptocurrency is, of course, that it's a catch-22, right? So cryptocurrency will be able to get around these problems for as long as nobody's using it, which is the current situation, right? So if you don't care that you can't sell to most consumers because most consumers don't use cryptocurrency, it will work because it is decentralized and the government is not involved, right? As soon as the market for cryptocurrency broadens to include the actual majority of customers, the government will be involved immediately, and it will immediately change over the course of a year or two into the exact same situation you have right now with all other payment processors, and it will be identical to MasterCard. I don't know why people don't understand that. It's so clear because they have an army. What are you going to do? Like, I don't know why people think cryptocurrency solves this problem. The people with the army decide what you can do with your currency. It doesn't matter who stores it or how centralized it is. The government doesn't have any control over cash. Like, you hold cash in your hands, it's completely decentralized, right? You can go pay for drugs on the street corner with a wad of cash, and the government doesn't know anything about that transaction. Guess what? They deploy literal people in body armor with guns to stop you. What is the Bitcoin going to do, right? They will just come into your house and take you. It doesn't matter that it was cryptocurrency. So it's such a freaking pipe dream. It's just so stupid, right? Like, cryptocurrency solves nothing. It is only able to evade legal control over its use while it is unpopular. As soon as it gains enough popularity, the laws will be placed such as to render it no different than any other currency, and at that point, the entire endeavor was a waste of everyone's time, and more importantly, a gigantic waste of actual energy that we had to actually pay for by burning coal or something. Yeah, it's so ridiculous. Like imagine the post-apocalyptic world. Like, anyone's going to use cryptocurrency. Where are they even going to get the electricity to run the GPUs? Right? It doesn't even make sense. Crypto is totally useless. It is a solution to a problem we've never had and still don't have. Right? It is a solution to a problem that nobody needed solved. Can I make my camera bigger? I can, except I was supposed to be done. This was not supposed to be... I was supposed to be done. We weren't supposed to still be talking. When I make the camera bigger, it looks like this. Ooh, this was a little too close to the frame, wasn't it? There we go. I mean, NFTs are... I mean, they're just a Ponzi scheme. There's not much to rant about there. Because I don't know that anyone's been, like, promising... I don't know. An NFT is sort of like a certificate of authenticity, you know? It matters to people who are trying to determine whether a particular item is the actual item or not. Why we care about those things, I don't know, because they only matter to rich people who want to buy things like art at an auction. There's otherwise no value to a certificate of authenticity at all, because if you think about the actual utilitarian value of any given item, if I think something looks like the Mona Lisa, to me, when I hang it on my wall, that was as good as the actual Mona Lisa in practice, right? So NFTs also solve a problem that no one has, except you might consider them solving a problem that no one we care about has, which is specifically extremely rich people buying, like, art on the internet. Is the only... so it solves a problem that society definitely doesn't have, but that a small niche of people maybe do. I don't know. And yeah, Demonics, I would tend to agree. Like, I'm not sure that the NFT actually... So when I say solves that problem, what I mean is it serves the same purpose as a certificate of authenticity. Meaning that, much like a certificate of authenticity, it could be wrong. You know what I'm saying? Like, when you get a certificate of authenticity that this is actually the Mona Lisa, all you know about it is that some experts who examined the item believe that it is the Mona Lisa. You don't actually know because you can't actually prove anything about it, right? And NFTs are the same way. You know that somebody signed it, and you might even know that the person who claims to have made the work has signed it, and that's maybe something, but you don't know that the person who claims to make the work has actually made the work. You don't know whether that key ever got stolen or forged, especially not in the case of something like the Mona Lisa where the person's dead, right? So yeah, so I wouldn't say that NFTs can't serve some purpose. They just don't serve a purpose anyone should care about, right? They serve the same purpose as a certificate of authenticity, but a certificate of authenticity itself is useless to almost everybody. It's only a very small group of people who will ever care about that. And so, much like cryptocurrency, I don't see why anyone really cares about it. And the bottom line is that for the average citizen in an average situation in society, they care about mass-produced art. Like we care about being able to go and watch, you know, Avengers Endgame or something. Nobody asked when they walked into the theater to see proof that the Avengers Endgame they were watching was actually the one that Disney made, because nobody would bother to forge it. It doesn't even make sense, right? So to the average citizen consuming something, they almost never care about the authenticity of that thing because it is societally verified already, right? Like I don't need Netflix to prove to me that the second episode of Mindhunter was signed by David Fincher. Like, I've never asked for that in any context, nor have I ever even thought of a reason why I would need that. It just doesn't make sense, right? So NFTs, again, they're not really for anything we care about. They're basically to like, you know, to continue propagating a kind of stupid model, which was like niche, singular artworks for rich people who buy them at auction. Like, I don't know why we care about that. I don't know why we'll ever care about that. I certainly don't care about it now, and I can't imagine caring about it in the future. So NFTs, no idea why they're important. Jazz Rabbit, no, art has value to the person who bought it in an open commerce duplicated setting, right? When I buy a painting to hang in my room, I shouldn't care, for the purposes of seeing it in my room, whether it was authentic. Because what does that mean? I should just care that it looks nice above my sofa, right? That's what art does. This is what I'm trying to say with, like, Avengers Endgame. Like, it wouldn't be a better movie. I mean, first of all, I didn't like the movie, but let's suppose you cared. It's not a better movie if I know that I'm seeing the, like, first print of it, right? It's a niche, weird, fetishistic space of overvaluing objects for some reason unrelated to the actual act of looking at them. If I can't tell by looking at it whether something is the actual Mona Lisa or a forgery of the Mona Lisa, the value is the same to me. Right? Period. And we know this is true. Nobody cares about these things. Like, the things that people spend all their money on, like someone's bringing up the example of the Louvre. Like, no. The amount of money spent at the Louvre compared to the amount of money spent on Avengers Endgame is a joke, right? Like, the world cares about just regular consumable art. They do not care about what's hanging in the Louvre. Like, full stop. It's a tourist destination. People go there to have something to do. Furthermore, if you replaced all of those paintings with forgeries tomorrow, people would still go there and say the same thing. They wouldn't even know. They would have no idea, right? You replace the Mona Lisa with a good forgery tomorrow, not a single person who goes to that gallery would have any idea you did that. And you know what? That's not even hypothetical. I think there's literally been times when there have been forgeries hanging in these galleries, and nobody knew. Is that true, John? Do they really hang fake ones a lot of the time so that they don't get damaged by flash photography? I mean, I'm not surprised. Because, like, nobody knows. It's you can't tell. Not only that, but if you were the kind of person, there's some people who can probably tell. Like the difference between the real Mona Lisa and a fake. There's maybe some people you're not allowed to get close enough to a lot of these images. There's like a little cordon around it. You can't even get that close to it, right? So it's not like you're up there with your face like pressed into the Mona Lisa, looking at the little like brushstrokes and going, ah, I noticed a difference. I think this is the fake. Like, that's not how you can't even. Like, a poster of the Mona Lisa would look like the Mona Lisa from how close you're allowed to get to the thing. The Mona Lisa does seem shockingly small. I've never seen it in person, but when you look at like a wider shot of like the place where it's hanging, it is very tiny. It's not the original piece that's valuable, though. It's just the thing that is, like, in your example, people still buy that game 2 years after. And it's just a duplicate. Right? It's just a duplicate copy. It's not the original copy. There's like a fetishism around the original copy of things. You see this even in cases where they're non-differentiated. The first printing of a book for collectors is more valuable than the second printing of a book. Why? There is no reason. It's just arbitrary, right? It's like an arbitrary rule people made up so that they could sell and collect things for more money. And that's it. It's pure arbitrariness. And so that's what NFTs are. They're a way to bring that pure arbitrariness into the digital age. So, and to that extent, I have no problem with them. I think it's stupid, just like I think auctioning off like those items are stupid, because I don't think it should matter, right? But there's nothing more stupid about it, right? There's nothing more stupid about NFTs than about wanting specifically the original Mona Lisa instead of another Mona Lisa, even though you can't tell the difference, right? And as for like producing excess CO2, that's kind of separate. So you can criticize the implementation of certain things, and you know that's fine. But the idea, if you could solve that problem, produce them with solar energy or whatever, then again they become the same as a certificate of authenticity. I don't have a problem with that, but it does seem it all just still seems like a waste of time, right? I don't see how NFTs help you support an artist when we already have ways of doing that, right? Like we already had Kickstarter, so we already have Patreon. We already have the ability to mass produce and sell games on like Steam. Like, what is the point of the NFT? It seems to me to be trying to overvalue a work of art to try and get more money out of it than its actual societal value produced, right? That's what it seems like. What about using an NFT for creating a digital used market? But digital used markets are bad, right? The problem with the digital used market is now that means that the price of the original games increases. By not having a digital used market, it means that the price of the games decreases. It's why you have so many games now that sell for $5.99, $9.99, $15.99 instead of $60, right? It's because they can't be sold used. So instead of selling, you know, a third the number of copies because people buy them used, you just sell the actual number of copies and the price goes down by a third, which is exactly what should happen, right? The idea to want to be close to the actual thing that Da Vinci touched with his hands is somewhat relatable. Not important for you, but it's certainly not arbitrary. It's pretty freaking arbitrary. Would you apply that to all the other things that Da Vinci touched? Like, oh, yeah, like, you know, he probably touched this toilet handle. Or this, it wouldn't be a toilet handle. It would probably, I don't even know if they had functional toilets for Da Vinci. So this chamber pot, right? Like, oh, I gotta touch this, you know, chamber pot. It's just romanticizing things arbitrarily. It's totally arbitrary, right? Like, some of Da Vinci's DNA is in some descendant somewhere. Do you go, like, touch them? Do you, like, touch their face with your hand? I don't disagree that this exists, right? It totally exists. It's still arbitrary. It doesn't serve an actual purpose to allocate resources towards things that people actually use, right? So that's why I don't see it being particularly important. If you look, like, so you look at things, and, like, the reasons I say Avengers Endgame versus NFTs, Avengers Endgame is things lots and lots of people wanted to go do for some reason, right? That means that putting the money towards that was useful to society because it actually has value for a humongous tranche of society, like 300 million people or whoever, right? The people who care about a pixelated whale being certified as authentic via an NFT is like 3. It's not a good way to allocate money. It does not produce a lot of value to society to allocate money towards the pixel whale, right? And the same is true of certificates of authenticity. It doesn't actually produce hardly any useful value to society to know which Mona Lisa is the actual Mona Lisa. It doesn't, right? It's a waste of actual resources to have these auction houses, to have experts who can identify the actual Mona Lisa from the real one if they even can, to have security guards guarding the Mona Lisa because it's the actual Mona Lisa and not another one and therefore worth a tremendous amount of money, to have to maintain a museum to keep it there. Like, none of that is producing useful value. It's all a waste of time, right? Like there is an actual thing that we have to do, which is to take the money and spend it on something. And you can either spend it on something that tons of people actually go to do and get value from, or you can create an entire arbitrary, useless system that produces nothing. Like, literally, it's actually the opposite. It's a system for preventing you from producing more Mona Lisas. Why? Right? That's why I call it arbitrary, because it's like, we just made it up. We totally freaking made it up. And it's basically only rich people. No one else is doing this, right? Because it's not like other people just buy a print of the Mona Lisa. And it's worth like $20, right? So by arbitrary, what I mean is that it doesn't actually use money to create something anyone wanted. Right? It's just we created a arbitrary thing to make money that doesn't actually produce anything. Arbitrary is probably the wrong word. Fictional. Like, fictional value would probably be the right term. Right? So real value is when you don't need a certificate of authenticity because the act of using or experiencing the thing is of itself, it is the value. The certificate of authenticity means that that thing didn't have the value because the person experiencing it obviously can't tell, otherwise they wouldn't need the certificate, right? So it's completely arbitrary. It's creating arbitrary value that doesn't actually exist because no one can actually determine the difference, but we created an arbitrary value there by just claiming that there is a difference between one of the things and all the rest of the things, even though no one can tell, right? That's what I mean by arbitrary, but really maybe I should say is fictional. It's fictional value. It's value that definitely doesn't exist because if you remove the certificate of authenticity, no one would be able to tell, right? Now, there is a difference, for example, between a crappy reproduction of the Mona Lisa and a good one. That's actual value. If someone actually looks at the Mona Lisa and says, oh, this one looks much nicer than this other one, it's like a crappy copy, that's actual value. Because someone actually might prefer one over the other. They might pay you more for the better one, right? For real. You don't need to convince them of something like this one's original and that one isn't. Yeah, and I don't think it's the right question to say, does art create value to society or not? That's not really what's important, right? Because if you think about society and economic systems as ways of people deciding what has value to them, right? Then this all works just fine. My point is simply saying that if a certificate of authenticity is what switches something from being worth almost nothing to being worth a fortune, right? That is a fictional value because it doesn't actually allocate money to any particular place, right? It doesn't actually allocate funds towards doing something useful. It allocates funds towards something arbitrary, which is a certification system, right? Again, obviously people do care about this. How do we know that? Because they do it. Right? So it's not like I'm saying this doesn't exist as a system. Of course it does. We can see that certificate of authenticities already exist. What I'm saying is it's a useless system. It doesn't allocate money towards actually ever making anything. It allocates money towards not making something, right? And that, to me, is a very fictional, unproductive way of structuring anything, right? So I think the question, Jazz Rabbit, your question of what should be the price of the Mona Lisa, every copy of the Mona Lisa should be 1 million or, well, let's use the first part, so I probably need. What should be the price of the Mona Lisa? This gets to the actual reason that I'm talking about this. So in the real world, when you ask what should be the price of the Mona Lisa, then you get into the problem of like, well, okay, you can see why you created authenticity and all these sorts of things, because it's like we wanted to have a market for this thing so that you can pay for it or whatever, right? Because in theory, there will always be a difference between the original Mona Lisa and a copy of the Mona Lisa. There is a difference, right? So we then get swept up in this whole discussion about like, how do you value the fact that there is a difference between these two things and all that other stuff, right? The reason that I brought this up with NFTs is because NFTs don't have that. There's literally zero difference between the original Mona Lisa and a copy of the Mona Lisa in NFT land because it's digital, So that's why this system makes even less sense, right, if you will, once you start to think about the fact that there's literally no difference between those things. Because someone could still argue that even the best forgery of the Mona Lisa is somewhat different than the original. Right? Like, maybe we can't really just, like, totally reproduce it to within human perception. You know? With NFTs, that's totally gone. You know it's exactly the same. So now we are literally just trying to make up a reason why we can sell this thing for more than what it's actually worth in its duplicated state. And I just don't think that leads to good outcomes, right? It seems like outcomes should be based on allocating money based on the fact that we know that digital goods are exactly reproducible. Well, my assumption is NFTs are a bubble. I can't imagine anyone will ever really... Because, again, when you go to the Mona Lisa thing, at least the romantic idea of the original Mona Lisa is at least slightly different than a forgery. That, or like what someone said before, like Da Vinci's hands touched this, right? Those things don't exist at all in the NFT market. It's just bits. The person didn't touch them, right? They were just copied inside a computer. There's no romantic notion at all. It's exactly the same. No one ever touched it, right? It's the same. So it'd be really hard to sustain that ruse. Everyone knows it. Everyone knows it's exactly the same, right? Yeah, you have to buy. Yeah, do you think Da Vinci would have rage quit because Wacom tablets are so crappy now? Also, so here's another question. So, assuming that the great masters all used an iPad Pro to do their painting, would they all have been arrested by the FBI when Apple sent their pictures as child porn to the FBI because they all paint little naked babies all the time? Like, if you go look at, like, the Sistine Chapel, there's, like, naked babies everywhere, right? Like 90% of the stuff covering, like, all these surfaces are little, like, cherubs that are obviously babies and they're obviously naked. So would Apple just flag all of that? Like, does Apple just flag Rome as the FBI has to go there and arrest everybody? Right? They're like, Rome is under arrest. Of course, actually, as I'm saying that too, like, it's the Catholic Church, so actually if they had sent the FBI there and arrested everybody, they'd probably just be ahead of the game because that's what the FBI had to eventually do anyway. So maybe I take that back. But point being, you know, I feel like there's maybe a problem there. But yeah, I mean, as I said that out loud, I was like, wait a minute. Actually, you know, the Sistine Chapel is maybe the one place where if Apple had sent them to arrest everybody, they probably would have just been fine, because that's probably, you know. if the value of art is arbitrarily decided by people, why can't originality be arbitrarily chosen as value? It can. And it is, right? I mean, it has been. That's why I was saying, like, Certificate of Authenticity, original Mona Lisa, right? It has been. What I'm saying is that it was a bad idea, right? That was a bad arbitrary decision, because it doesn't actually involve people paying money towards something they actually need, right? It's the same problem as $1 million car. There really isn't any use for it, right? It doesn't really do anything for us that there are all these people working on making this really, really expensive car. It doesn't really even lead to new information in the same way that, say, the moon landing did or something like that, right? So you just have to look at how you allocate money as a society. Extreme luxury items tend not to be very useful to society. They're basically just like a thing for rich people to do that don't actually have many, that don't actually allocate the work towards things that are generally benefit people, you know? So like $100,000 car maybe makes some sense. $1 million car, now you're up at the place where it's not about, hey, this is where we work on new technology. It's really just about us trying to figure out ways to make this car be worth $1 million for no reason, like gold plating it, or doing weird by hand stitching of all of the things around it, or like just stuff that is completely useless, but it's just like we had to come up with ways to make this car be worth $1 million, right? That's the original Mona Lisa. That's all this stuff. It's ways of coming up with making things be worth $1 million for no reason. Just because you know there are people out there who will pay the $1 million. The sealed Mario cartridge that was like $1.5 million. That's like the dumbest thing I've ever heard, right? But that's all these things are. They're just ways of trying to manufacture value in a place where it doesn't really need to be. And by putting money there, it doesn't disappear, right? That money doesn't just go into thin air. That money goes into the infrastructure necessary to support that. That infrastructure is useless. Auction houses are useless. Authenticity verification is useless. It doesn't provide any new things for society, right? So it's just waste. That's the point, where it's creating waste. Nobody else benefits from it. It's all of this infrastructure, all of those people who were doing all of that stuff would have been better employed doing something else, right? So you're, right? I mean, that's economics, right? Economics is how do you allocate labor? That's what economics is, right? And you look at these things and you say, are NFTs a good way to allocate labor? The answer is absolutely not. Like, I defy anyone to show me some economic model under which an NFT increases the accuracy of labor allocation. Like, it just doesn't happen. Priceless art is exactly the same way. It does not allocate any useful work. It's all wasted work. Yes, video games are very productive, right? So if all the people who were curating and verifying priceless art were making video games, that'd be great, because everyone can play those video games, right? The billion people in the world who play video games are benefited, right, by more people making more video games. They have better selection, they have better quality, right? So you said that as a joke, but no, that's what I'm saying. Making things that other people can use, that the average person can use, that is creating value. Spending time doing something that is literally useless, I'm just verifying this thing, right? Nothing came of that. That person's labor disappeared. Remove the phrase arbitrary, think permanent. Did the labor create something permanent? Verifying the authenticity, running an auction, etc., it creates nothing. It's completely wasted, right? If those people had instead been doing something that created something for society, that would definitely have been a win. Yeah, permanent or consumable, right? Like something that someone can eat might be considered fine too, right? Even pyramids would be better, right? Because at least it was something. At least it existed. But I agree, I don't know that you want to optimize for building useless structures. It seems similar to NFTs. But at least it's permanent. You could use it for living space. I mean, you could do something with it eventually. At the minute, it's just a tourist trap, but... All right, I'm tired of talking. To me, this stuff is kind of just obvious. Like, I'm not sure why I'm even talking about it. Like, there are so many things that need doing that I just don't know why you would spend time creating things that don't need to be done, right? Which is basically what we're doing with both crypto and NFTs. It's just things that nobody needed, and you're just creating them for no reason. And they don't actually exist, right? They're just fictional constructs. And it's like all of that energy, all of the work, all of that stuff could have gone into something else. Something that someone could actually use. A video game, a, better web browser, better chip designs, whatever those people could have been doing, it all would have been better than NFTs or crypto, right? And especially when you think about the fact that NFTs and crypto are actually, they're somewhat complicated. So it's not like these are completely, useless employees who couldn't have done anything else. They're people who probably had some capabilities, right? Like this is work that could have been allocated better. And I don't know how people are actually arguing that on the chat. If you really think that NFTs and crypto were like good allocations of money, or labor is really the thing, because the money is just a proxy, right? So if you think they were good allocations of labor, that's what labor should be spent on. I really don't know what to say, but... So the anti-bank, anti-government ideological strain of crypto is actually fine. The problem is they're not solving those problems. That's really my complaint with it, right? Like, I like the idea that you could have like a libertarian currency, because we see so many problems, like things like with payment processors, shutting people off and whatever. You saw that with the OnlyFans thing just recently, for example. The problem is, cryptocurrency doesn't solve that problem, right? The government will still be able to regulate it any way they want because they have the army, and they can just come to your house and arrest you, right? So it doesn't really help. And so really my complaint about crypto is not that I don't want to solve the same problems that they claim to be solving, because I would love a solution to that problem. It's more that I don't see how any of the things they're making actually solve this problem. That's the problem. Like, if someone could figure out how to make the universal distributed government, then great. But what does that even mean? That sounds terrible. Like, mob rule is the only thing I can think of that sort of is that, and we kind of have that on Twitter, and it's terrible, right? So I don't see the solution, right? I don't see the solution. The payment processors aren't the government, though. They're a private institution who don't own a military and couldn't stop selling crypto. No, they can, right? So think of it this way. Whoever are the people who are running the Bitcoin mining, they're the new payment processors. They will just be pressured by the government in exactly the same way the current payment processors are, and they will enact the exact same sets of limitations for the exact same reasons. It literally solves nothing. Midnight Sun, I don't think I know what the I'm sorry, I don't understand the argument. I don't really think it has anything to do with the password, because a password is something that only you know, right? So it's useful in that sense. Crypto does not have that property. If you want to conduct a transaction, the transaction has to be able to be backed up by a court of law and a government. If it doesn't, the person can simply not honor the transaction. I go to the grocery store and I use my crypto to buy a grapefruit, and as I walk out of the store, the person says, "Oh, you can't have that. You stole that grapefruit." What prevents that from being a real problem in society is the fact that there are courts. They look at evidence. The government has police. They enforce that law, and the result of what happened in that court, that's how society functions. Crypto doesn't have any answers for any of those things. That's the problem, right? And so crypto needs that. It needs courts, police, law, right? That is what makes a currency actually work. Not that you can track an integer. Tracking an integer doesn't do anything for you. We can track integers with just a server, right? The problem is, what happens when people disagree about whether someone who agreed to do something for that integer doesn't do it, right? I took 2 grapefruits, but I only paid for 1. Well, my point is just, in general, broadly speaking, the government has the police power. So they're the ones who can say what will happen and won't happen, and that's pretty much the end of it. And the reason that payment processors do what they do is because of the government regulations. Payment processors don't care, right? All right. Couldn't society decide that we switch to crypto for our currency and change the laws accordingly? So you could, but if you could do that, you don't need to switch to crypto. Like, if we just passed a law tomorrow that said that everyone had to accept, transactions from everybody, that would solve the problem. But you don't need the crypto, right? So if you have, this is why I say crypto is worthless, because if you have the political will to create the laws that you actually wanted, you could have created them without crypto. You could have just said that for dollars, there can be no discrimination in charges. You have to process charges from anyone for any reason always, right? And number two, you what's the other thing that crypto claims to solve? I don't know what they do. Oh, and that no one can ask. Right? No one can ask, no one can subpoena your transaction records. Right? You pass those two laws, you're done. Now you've got everything that cryptocurrency ever promised. Right? That's it. Yeah, and okay, so the non-subpoenaing part is giving crypto the benefit of the doubt. I do realize that in actuality, I think most cryptocurrencies, yeah, they haven't actually solved the problem of privacy. So, but let's suppose someday they did. Somehow. So. All right. That's it. This is all very stupid. I'll see you folks next time.